Hi friends, in this video series, we are developing and deploying AI agents using different services from GCP, AWS and Azure. In a previous video, we have built an AI agent which enable the customers track their order status by interacting with the agent in a natural language. Okay. Today, we wrap the agent in a FastAI application so that one, we can create endpoints and the client applications such as mobile, web app, etc. can interact with the agent by making HTTP requests. Okay. All right. So we will be using FastAPI to wrap our agent and Pydantic to enforce the input as well as the output data types from the agent. We have used Agno agentic framework for building the agents, for accessing the LLMs, and creating some database tools for the agent so that it can understand the customer's order data within our database and also write SQL queries to extract the order status. Now, if we want to persist our agent interactions in a storage, we can either use Postgres SQL, SQLite, or any other database. All right. So in this .env file, we have some credentials like OpenAI API key, and depending on where our database is hosted, we might have the database URL, etc. Okay. Now, if it is a Postgres database hosted on AWS or elsewhere, which is what we did in a previous video, we can create a SQL tools by simply supplying the database URL to the SQL tools module, okay, which lets the agent list the tables in the database, the schema of each table, so that it can understand the customer query and write a SQL query to execute on the database. All right. Now this one, the storage, it is for storing the interactions with the agent. All right. Again, here we are writing to the same database, and this is a new table where we are persisting the interactions. Now, either you can continue to use this Postgres SQL, but from now on, to keep it simple, we will use a SQLite. Okay. So I have created this orders SQLite DB where I stored all the customer orders along with their status, order status, etc. Okay. So just as before, we create SQL tools based on the SQLite database. All right. And then for storing the interactions, here we are creating another database called Agent SQLite, and within the database we are creating a table called Agent Sessions, which is where we store all customer interactions with the agent, the tools, tool calls, session IDs, etc. Everything. All right. We have a simple prompt. Basically, it says, okay, you are an AI assistant. Your job is to help the customers track their order status. If they don't provide the order status, politely ask, etc., etc. All right. So Agno is a very high-level agentic framework, making it very easy to create these agents. So with this module, we can create the agent, give it a name, an LLM model, the storage. Some of these are optional. So this is for storing the interactions with the agent. Just the output markdown. For debugging, we can enable the show tool calls to true. And then we have the agent prompt. Here we have the SQL tools. Those are the three tools. And this one, since it is going to be a chat type of application, we want to enable or we want to append the history to the current message so that the agent have the full context of what the customer is talking about. All right. So what's new is here we are creating a FastAI application. We are calling it app. We can give it some title, description, etc. Now using Pydantic, we are creating two classes, one for input to the agent, the other output from the agent. Now this is a very simple application. The agent takes text as an input and gives text as an output. In between it is making some tool called SQL, writing some SQL code, etc. But the input and output, both a simple text. Okay. So here we create a class called chat in using this Pydantic base model. It takes this message as an input, which is of type string, and the description, it's a customer message. Okay. Similarly, we have chart output. It's the response from the agent. It's basically the response from the agent, and it is of type string. Okay. So very two simple classes. All right. And then we create these two endpoints. So one is these default root endpoints just to check the health of the application and if it is up and running. Okay. So it is the root, that's the endpoint. The status goes 200. So which simply, when invoking this one, it's a get method. It doesn't take any input. When we invoke this endpoint, it simply displays this message: the order tracking AI agent is up and running. Okay, but we are more interested in finding the order status, right? So next we have this post method, which take the user message as an input, okay, and the output, the response model, it's the chat output as we have described here. And then we have this function which takes chat in as an input. Simply we invoke the agent with that message, we get the response, and if the call is successful, we send the response back to the client application. Okay, a couple of optional ones like this markdown true, that's the output format, the stream, depending on, I mean, these messages are going to be very short, so it's no point enabling a stream to be true. But if we have very long messages or outputs from the agent, maybe we can enable true, so that the customer will have seamless experience. They don't have to wait for a couple of seconds. They can see the response as it is being generated. All right, now one important variable here is this session ID. Now here we don't really have a client application to invoke the agent. We will be invoking the agent in different ways, but not really client applications. So we are not sending this session ID, but the session ID is important because it groups the conversations or the messages related to a particular chat. Okay, all right, so that's our application. And to run the application, all we need to do is okay, so just run this command, uvcon app:app. Now this is very important, this app:app. App is the our script name, okay? This is the script name. And then our FastAI application name is also app, okay? So those two has to match with this app:app. Sometimes you might have main:app, etc. if main is your script, okay? All right, so we are hosting it locally, and this application is served on port 8080. All right, so the reload is if you are making any changes to the code, we want to automatically update the application to get updated. All right, once we do that, so we will have this endpoint. Yeah, we'll have this endpoint. Okay, so let's go here. So first, let's just go to the root. Yeah, so as you can see here, it's a get method. It simply displays this message: the order tracking AI agent is up and running. So it's this root method. So we just invoked this endpoint. Okay, so it simply displays this message. Now, the advantage of using FastAPI AI is it's the documentation. So if we do this /docs, so it displays what is called this Swagger documentation. So here it lists all the endpoints we have created. For example, the get one. So try it out, execute. It simply displays this message: order tracking AI agent is up and running. Okay. Now, if you don't know, all this information is super useful. It shows the input. Maybe I'll show you this one. Okay. So it shows for each endpoint what's the expected input, the output format, the structure of payload, etc. Right? So in case if you don't know this FastAPI documentation, please have a look at it. It's super useful. All right. So let's invoke the chat endpoint. Okay. So here it says this is the input is simply the message, which must be a string, and here is the application type, etc. And let's invoke it. So try it out. Okay. First, let's just say hi. Now, these endpoints are integrated in a chat type of application for the customer to have seamless experience, but here we are invoking the endpoint directly. So let's just say hi. So the agent must come back and say, hey, I'm here to help with your order status. What's your order status? Something like that. Okay, hello, how can I assist you today? If you need to track an order, please provide your tracking ID. All right, so let's say my tracking ID is T1234. Okay, now let's execute it again. It's a bit slow, but it says, okay, your tracking status is as follows. The name is John Smith, and the status is it's already shipped. The expected delivery date is August 31st, 2025. Okay, now let's give an incorrect order status, but this time let's just give the order tracking ID to see if it can figure out that this is the tracking ID. So it says it looks like the tracking ID 3999 doesn't match any records in our system. Can you please check the tracking ID and provide it again? Now, here we said we have enabled the memory, right? So here we said add history to the message as true. Let's test it by asking what was the order ID I have provided? Sorry, what was the order ID I gave? Let's see what it says. Okay, so it says the tracking ID you provided earlier is T9999. Okay, so it's working as expected. Now, this documentation is good, as I said, because it shows you the expected input, the format, the payload type, etc., etc. But it might not be too convenient every time. You don't want to go here and type things. So I will show you 3 other methods to test this application. Okay. All right. So using the Python request library. So our endpoint is this 0000, which is localhost 880, and our endpoint is chart. Okay. Now sometimes the localhost can be 127.0.0.0.0. So just check in case if this endpoint doesn't work. Okay. And then here we have payload with just one variable, a message. So what's the status of my order with tracking ID T1234? Now, as I said, if this request is coming from a client application, the client application create a session ID and use the same ID for all that in chat, okay, for that particular chat. All right. So here we have headers, the accept and content type. Now we invoke the endpoint using request post library. Here we have the endpoint headers and payload, and just get the response and run the response. All right. Let me. Okay, I think I just ran it, so maybe I'll show you. Okay, so simply running this Python code, Python test_tab.py, and here is our agent response as expected. Okay, so that's the second method of testing. Now the third method, we can also test using curl, which you might have noticed from our FastAPI documents. So here we have the curl command, right? So we are using the same one. All right, okay, same URL. Here we have the data, the customer message, and post request. Again, the accept and content type, we simply provide our data along with the endpoint. Okay, so that's a bash command. We can execute that as a bash script, which is what we did here. And here is the response from the agent. Okay, so that's the third method. Now, if you are familiar with Postman, let's do via Postman as well. So again, our endpoint, it's a post request. Okay, it's a local one. And then we don't have any parameters. And for authorization, choose no auth. This is important, otherwise it wouldn't work. Then for the headers, accept application JSON, content type also application JSON, and for the body, here we simply supply the user message. Okay, again, what's the status of my order, and here you see the response. Okay, so those are the 4 different methods of testing the application. Now, when we deploy the application on cloud, it's pretty much exactly the same, except that the endpoint will change. Okay, and depending on if we accept all requests or not, we might have to provide authentication as well. Okay, it could be in the form of basic auth or token, etc. Okay, all right. Now, finally, I just want to show you how I created this orders SQLite database. Okay, so here is the script. I upload the script to my GitHub so that you can access it. Now, so we are using a SQLite 3. All right, here we are creating a database. If it not exist, order SQLite.db, and we connect to the database, and we create a table schema. Right, within it, we are creating this order status table, tracking ID, customer name, order date, status, expected delivery, and some delivery notes. Okay, all right. Now, most of the variables we define as they are, but we want the dates to be relevant to it, right? So we are using date as a variable here. So for the orders date, we are just going back in time. We're randomly picking some dates from today's date to create the order date. And similarly, for the expected delivery date also, we are giving some few days in advance. For example, this one, it's 3 days back from today, which means this must been already delivered, right? So you can test the application if it's delivered, what message the agent shows, etc. Right? So there is all types of variation. So we created some synthetic data, and we have ingested to our database. Okay, and then we can read the database. We can read the same database, and here we are printing the top 5 rows, as you can see here. No, let me run it. Okay, so here are the 5 records, the top 5 records. The first customer, Jan Smith, the order date, the order status, expected delivery date, and if there are any special notes, etc. Okay, so up to you. If you want to keep it simple, just run this script so that it will create this database and copy the database to wherever you are hosting the application. Or like we saw in the previous video, we can have a Postgres or any other database hosted on a cloud, and using the connection string, we can work with the database, live database as well. All right. So we completed this process. So in the previous video, we built the agent. Today, we wrap the agent in a FastAI application. And in the next video, we containerize the whole thing so that we can take it to anywhere and we deploy the container. And we will be deploying on GCP, AWS, and Azure. Right, that's all for this video, and all the code is on GitHub. If you have any questions, do let me know. If you find this content helpful, please support and share in your network. Thank you very much.